Alright, what about a non-monic quadratic equation? Well, the process is exactly the same. Make it equal to 0, this one already is, it's in standard form. Make it equal to 0, factorise it, apply the null factor law. Now this one is non-monic, but actually it's a monic quadratic hiding because there's a common factor for all of these. It's 3. So that's the same as saying 3x squared plus 5x plus 6 equals 0. Now it's a monic quadratic. I need two numbers that multiply to give me 6 and add to give me 5. Well, those numbers are 2 and 3. So it's 3. I will split them up. X squared plus 2x plus 3x plus 6. I know I don't have to. I can go straight to x plus 2x plus 3. But I want to keep doing this because the next ones that are non-monic, I will have to do that. So it's 3. Now factorise the left two terms. X plus 2. And the right two terms, 3x plus 2. And I should have a common factor, x plus 2. So it's 3x plus 3x plus 2. It doesn't matter which order you write these in. Okay, if this is equal to 0, then at least one of the factors must be 0. But 3 can never be 0. So, therefore, x plus 3 is 0, or x plus 2 is 0. Which means x is negative 3 or x is negative 2. And those are my two solutions to that quadratic equation. Again, notice carefully, the factorisation gave me positive numbers, but the solution to the equation is the negative numbers. Now it's going to get a little bit trickier when I give you a true non-monic quadratic. It's going to be 2x squared minus x minus 15 equals 0. Now here, there's no common factors. So I have to factorise it as a non-monic. I need two numbers that multiply to give me negative 30, remember 2 times 15, and add to give me negative 1. Well, the product is negative, which means I need different signs for the two numbers. So they have to differ by 1. Again, if you get stuck, 1 times 30 doesn't work. 2 times 15 doesn't work. 3 times 10, they differ by 7. I need 1. 4 won't work. 5 by 6. Aha. The numbers are 5 and 6. I need a negative sum result, so the bigger number must be negative. Okay, here I can't just write x plus 5x minus 6. Doesn't work that way. I have to split this term up. If you know one of the other methods, the cross method or one of the other ones, that's fine, you can use it. I'm going to show you from first principles. 2x squared plus 5x minus 6x minus 15. Now this might have looked a bit clearer if I had put these the other way around, but it will work just as well. Doesn't matter about the order. I'll show you. Factorise the left two. X. 2x plus 5. Now the right two, take out the negative factor and also 3. 2x plus 5. And you should end up with a common factor. So factorise. X minus 3 times 2x plus 5. Now, the null factor law says if the product is 0, then either this factor is 0 or that one is. Therefore, x minus 3 is 0 or 2x plus 5 is 0. Now this one's a bit more complex. This one's the same as we had before, so that means x equals positive 3. Notice that wasn't one of the numbers here. You can't go straight from here to the solutions for a non-monic. Positive 3, or what? It's going to take an extra step. 2x is negative 5, so x is negative 5 on 2. So my two solutions here are positive 3 or negative 5 on 2. Both of those will solve that equation. Now you might have been able to guess the 3, but I doubt you'd have got to negative 2.5 if you were just guessing an answer. Alright, so let's try a couple more. 10x squared minus 13x minus 3 equals 0. Again, first, always look for a common factor. Here, no common factors. So let's factorise. Two numbers that multiply to negative 30 and add to negative 13. Well, like last time, the product is negative, so I need them to need one positive, one negative, and they have to differ by 13. Wrote this before, 3 times 10. 3 and 10 are my answers. Yes, it's got to be a negative result. No, that's not going to work. That doesn't work at all, because these two numbers add if they were both negative to negative 13. That would be correct if this was positive 30. But it's negative 30. I need two factors that differ by 13. So I actually need these two numbers. Let me fix that. I need 2 and 15. They have to add to negative 13, which means the bigger number must be negative. Alright, let's split up that middle term. 10x squared plus 2x minus 15x minus 3. Okay, factorise the left two terms. 2x. 5x plus 1. Take out the negative term from the last two terms. Sorry, the negative sign from the last two terms. Negative 3. 5x plus 1. Change the sign because the negative's out. And I have a common factor. 2x minus 3 times 5x plus 1. Two complex factors, but that's okay. Either 2x minus 3 is 0, or 5x plus 1 is 0. Then, if this is true, then 2x is 3, positive 3, and x is 3 on 2. But if this is true, then 5x is negative 1, and x is negative 1/5. These two numbers, they're fractions, both of them, solve this equation. Let me do one more. This one starts looking a little bit different. It's not in standard form. 36x squared minus 21x equals 2. Well, I can't apply the null factor law unless it equals 0. So the first thing I'm going to do is write it in standard form. Minus 21x minus 2 equals 0. Make it equal to 0. Okay, now look for common factors. There are no common factors. So factorise. Two numbers that multiply to negative 72, it's a big number, and add to negative 21. If you get stuck, write out the factors of 72. 1 times 72, let me think about this just before I do. It's a negative product, so I need them to differ by 21. 1 times 72, 2 times 36, 3 times 24, they differ by 21. So my numbers are 3 and 24, and I have to have a negative result, so the bigger number must be negative. Okay, split the middle term. Plus 3x minus 24x minus 2. Factorise the left 2. 3x, 12x plus 1. Factorise the right 2, take out the negative sign, 2, 12x plus 1, and you can see I've got a common factor. 3x minus 2, 12x plus 1. Okay, null factor law says one of these must be 0. So 3x minus 2 is 0, or 12x plus 1 is 0. I'm going to have just enough paper. 3x is positive 2, x is 2/3, or 12x is 1, no, negative 1, so x is negative 1/12. And these two are two possible solutions to that original equation.